Claude Fable 5 can work on a task for days, not answer a question for a few minutes, not generate one extremely long response. Actually work. It can inspect files, write code, run tools, test what it built, discover that something failed, change its approach, and continue working on a problem for hours or even days. Anthropic describes Fable 5 as a model designed for long horizon agentic work. And in one example, Stripe reportedly used it on a migration involving a codebase with around 50 million lines of Ruby. The task finished in roughly a day, work that Anthropic says would otherwise have taken an engineering team more than 2 months. That sounds less like a chatbot and more like an engineer you can leave working overnight. But there is an obvious problem. Claude Fable 5 is still a language model. It still has a finite context window. Even with a 1 million token context window, 1 million tokens is not infinite. A long enough coding session can eventually consume it. Files are opened, tools return results, tests generate logs, plans change, errors appear. Claude writes code, reads code, rewrites code, and keeps accumulating more information. So how can an AI with limited context work for days? The answer is that it does not need to remember several days of work inside one enormous conversation. The model only needs enough information to continue from the current state. Everything else can live outside the model. Imagine asking Claude to build a large application, authentication, payments, database migrations, an admin dashboard, notifications, tests, deployment. Claude begins by reading the repository. It creates a plan, it opens some files, it implements authentication. Then it runs the application. Something fails. Claude reads the error, changes the code, runs the test again. Another problem appears. This loop can happen hundreds or thousands of times during a long task, and every step creates more context. The simplest solution would be to keep everything, every terminal output, every file Claude opened, every failed attempt, every previous explanation, every tool result. Just keep appending everything into the conversation. But eventually the context becomes enormous. And even before reaching the maximum limit, most of the old information may no longer be useful. So long-running agents need context management. One important technique is compaction. Imagine Claude has already been working for several hours. Its context contains thousands of lines of tool outputs, old plans, previous errors, and earlier versions of files. But Claude probably does not need all of that anymore. Maybe what actually matters is authentication is complete, the database migration is complete, these files were changed, this test is currently failing. The next task is fixing the payment callback. So instead of carrying the entire history forever, the system can compress older information into a much smaller representation. That is compaction. The agent does not need to remember every step it took. It needs a useful description of where the project is now. This makes the context window behave more like working memory. What Claude needs right now stays close. Older information can be summarized, removed, or stored somewhere else. And this leads to the second part of the system, persistent memory. Anthropic gives Claude a memory tool that applications can use to store information outside the active context window. That distinction matters. The information is not magically stored inside the model. It can be written externally and retrieved again later. Imagine Claude discovers something important on day 1. Maybe upgrading a library breaks another part of the system. Claude eventually discovers that version 3.8 has to remain pinned until a database migration is finished. That information might matter again tomorrow. Instead of keeping the entire conversation that produced that discovery, the system can preserve a simple note. Keep library X on version 3.8 until the migration is complete. Now the original context can disappear. Tomorrow, a fresh Claude session can read that information again. Claude did not personally remember yesterday. The system remembered yesterday. And software development gives agents another extremely useful form of memory. The project itself. Claude does not need to remember every line of code it wrote yesterday. The files are still there. The repository is memory. The file system is memory. And Git can act almost like a checkpoint system. Anthropic experimented with this when building long-running coding agents. Instead of expecting one enormous Claude session to build an application from beginning to end, the work can continue across multiple sessions. One session makes progress. It updates the code. It leaves notes about what happened. It updates the remaining tasks. It creates commits. Then another session begins later. That new session can inspect the repository, read the progress file, look at Git history, run the application, check the remaining tasks, and continue from there. Think about how a human engineering team works. One engineer finishes their shift and leaves a note. Login works. Password reset works. OAuth callback still fails. I changed these files. The current error happens here. Try this next. The next engineer does not need access to the first engineer's brain. They need the project state, the notes, the repository, and the tests. Long-running AI agents can work in a very similar way. This is why saying that Claude worked for 3 days can be misleading if you imagine one uninterrupted model thinking for 72 hours. That is not what needs to happen. Claude can work, make progress, store important information, compress old context, leave checkpoints, and then continue with the refresh context. The continuity exists in the system, not necessarily inside one gigantic prompt. But memory alone is not enough. Claude also needs tools. A language model by itself can only generate tokens. An agent needs a loop around it. Claude decides to read a file. The system reads it. The result comes back. Claude decides to modify the file. The system writes the change. Claude runs a test. The terminal returns an error. Claude sees the error and decides what to do next. Model, tool, result, model, tool, result. Again and again. That loop is what turns an LLM response into an agentic process. But tools also create huge amounts of temporary information. Imagine a failed test produces 20,000 tokens of logs. Those logs might be extremely useful for the next minute. Claude finds the problem, fixes it, runs the test again. Now those 20,000 tokens may have almost no value. Keeping them inside the context for the next 2 days would be wasteful. Anthropic supports context editing for exactly this kind of problem. Old tool results can be removed after they are no longer useful. The important conclusion can remain, but the enormous raw output does not have to remain forever. So the basic strategy becomes: keep what matters now, store what may matter later, remove what no longer matters, and summarize what is too important to delete but too large to keep. There is another major problem with agents that work for a long time. They can think they are finished when they are not. Imagine asking Claude to build an entire application. Several hours later, it has implemented 20 features. The app starts. Most things look reasonable. Claude decides the project is complete, but perhaps 30 requirements are still missing. Anthropic encountered this problem while experimenting with long-running coding agents. One solution was to give the agent an explicit feature list. Every requirement begins as incomplete. Claude works through them one by one. And importantly, a feature should not become complete just because Claude thinks it implemented it. It should be tested. That external checklist becomes another form of persistent state. Feature 1, passing. Feature 2, passing. Feature 3, failing. Feature 4, not started. Claude no longer has to perfectly remember the original specification across several days. The state exists outside the model. And this is why testing becomes so important. A long-running agent cannot simply trust its own output. It needs an external source of truth. Claude thinks the login feature works. Run the test, it fails. Claude fixes the code. Run it again, it passes. Now the project state can change. This principle goes far beyond software development. A research agent could have a list of unanswered questions. A data analysis agent could have validation rules. A migration agent could track how many files still fail. Long-running autonomy becomes much more reliable when done can be verified by something outside the model. And this reveals the bigger story behind Fable 5. When people talk about better AI models, they usually focus on intelligence, benchmark scores, reasoning ability, coding performance. Those things matter, but a model that is extremely intelligent for 10 minutes is not automatically capable of working reliably for 3 days. Long-running work requires something else: memory, state, tools, checkpoints, verification, context management, and a system capable of restarting the model without restarting the project. This is why Fable 5's 1 million token context window is impressive, but it is not the entire reason it can work for long periods. The context window is only the workspace. Persistent memory stores important information. The repository preserves the actual work. Git provides checkpoints. Tests tell the agent whether reality matches its expectations. And the agent harness coordinates the entire process. Claude is the intelligence operating inside that system. This is also why long-running agent tasks can span far more information than one context window can hold. The entire history does not need to exist inside Claude simultaneously. One context can do useful work, modify the project, write down what matters, compress what happened, leave the system in a recoverable state, and then another context can continue. Humans already work like this. A software engineer does not memorize an entire codebase. They open the relevant files, search documentation, read tickets, check Git history, write notes, run tests. Then they go home. The next morning, they reconstruct enough context to continue. AI agents are beginning to work in surprisingly similar ways. So when Anthropic says Claude Fable 5 can work on tasks for days, do not imagine a giant language model staring at the same conversation for 72 hours. Imagine something closer to a relay race. One context does useful work. It modifies the world. It records what matters. It leaves a checkpoint. Then the next context picks up the baton. The files survive. The memory survives. The tests survive. The goal survives. And Claude continues. The breakthrough is not that Fable 5 suddenly has infinite memory. It does not. The breakthrough is that an AI agent does not need infinite memory to perform extremely long tasks. It needs to know what matters now. It needs somewhere to store what will matter later. And it needs a reliable way to recover the state of the project when it continues. That is how an LLM with a finite context window can work for days, or